You know, artificial intelligence feels like limitless digital magic. We watch chatbots write complex code in a matter of seconds, and image generators just conjure up stunning art out of thin air. It feels entirely virtual, right? But here's the catch. Behind the screen, this digital revolution is completely bound by physical hardware. In this explainer, we're going to trace the incredibly complex, real-world roots of AI.
Is AI really just software? Well, if you pose that question to most people, they'll probably say yes. We're so conditioned to think of AI as pure code, just algorithms floating somewhere in the ether of the cloud. But pulling back the curtain reveals a completely different reality. The invisible infrastructure required to make artificial intelligence actually function is staggering. And let me tell you, it is anything but virtual.
We need to ground ourselves in this stark reality. The future of advanced digital intelligence, and really the very speed at which AI will progress, depends entirely on microscopic pathways carved into physical pieces of silicon. Think about that. It requires rare materials, massive factories, and vast amounts of electricity.
Part 1. The hidden AI system. So, if physical chips are the key here, who actually controls them? Well, it's not just one or two tech giants. It's not a single powerful nation either. Instead, we're looking at an incredibly fragile, interdependent global supply chain. You've got brilliant chip designers, the foundries that manufacture them, the companies building atomic-level equipment, memory suppliers, massive cloud buyers, and of course, the governments regulating the whole shebang. Every single entity here wields a distinct type of power.
Building an AI ecosystem is essentially like building a Formula One race car. Having a world-class engine is fantastic, obviously, but that engine is utterly useless without high-octane fuel, specialized tires to actually grip the road, the physical track to race on, and the regulatory rules governing the sport itself. Let's break down these components.
Part 2. Designing the AI brain.
The most visible layer of this supply chain belongs to the architects, the companies drawing up the complex blueprints for our Formula One engine. But to understand what they're designing, we first have to understand why traditional processors, CPUs, completely fail at AI. Training massive AI models requires executing thousands of mathematical calculations simultaneously. It's an entirely different beast. It requires a specialized architecture, an AI accelerator, typically a GPU, precision engineered for parallel processing.
208 billion. Just consider the sheer density of these blueprints for a second. That is the number of transistors packed into a single modern AI architecture, specifically NVIDIA's Blackwell. They are literally cramming 208 billion tiny switches onto a piece of silicon. It represents the absolute bleeding edge of human engineering. But a blueprint is still just a blueprint.
Part 3. The manufacturing bottleneck.
Because having the smartest blueprint in the world means absolutely nothing if no one can physically build it. And leading-edge semiconductor manufacturing is supremely difficult. Designers like NVIDIA are mostly what we call fabless, meaning they don't actually build the chips themselves. Instead, they rely entirely on a tiny handful of critical foundries, like TSMC, who operate the world's most pristine cleanrooms to fabricate these wafers. It's a massive physical bottleneck.
And the plot thickens, because even those elite foundries have a bottleneck of their own. They depend entirely on EUV lithography machines. These are extraordinary, boss-sized tools that use extreme ultraviolet light to print atom-scale features. And here's the kicker. There is essentially only a single supplier in Europe, ASML, capable of making these highly restricted tools. Without their machines, the most advanced chips simply stop existing.
Part 4. Memory and packaging limits.
Okay, so let's say you have the blueprint, you have the foundry, and you have the EUV machine to build a blazing fast processor. Awesome, but that processor is entirely useless if it's starved for data. And that brings us to HBM, or high bandwidth memory. If the processor is the engine, HBM is the specialized tires required to actually put that power onto the track. It provides massive data transfer rates, and once again, a very select few suppliers like SK Hynix, Samsung, and Micron control this critical bandwidth.
This creates a massive tension right at the heart of AI hardware. On one side, you have the blazing compute speed of the processor. On the other, the strict physical limits of moving data in and out of memory. To bridge this gap, the industry relies on highly advanced 2.5D and 3D packaging to tightly connect the compute and the memory. If this highly complex packaging process slows down, well, the entire global AI supply chain slows down right along with it.
Part 5. The power of demand.
Now that we've looked at the microscopic scale, let's zoom out a bit to the macroeconomic scale, because the buyers wield just as much influence as the makers. Enter the hyperscalers. These are the massive cloud providers like Amazon, Google, and Microsoft. They exert enormous control over the entire ecosystem through the sheer gravity of their purchasing power. We're talking about buying hundreds of thousands of AI accelerators and dominating the cloud platforms where businesses actually interact with AI.
But deploying these massive clusters creates what might be the ultimate physical bottleneck. Step 1 is sourcing the chips. Step 2 requires constructing highly specialized data centers to house them. And Step 3? Securing gigawatts of raw grid power. AI chips run incredibly hot. They require massive amounts of electricity and intense cooling infrastructure. So the ultimate limit to AI might not even be the chips. It might simply be finding enough electricity.
Part 6. Geopolitics and the future.
Overseeing this entire global map is the final, highest-level layer of control, national governments. Recognizing that AI is arguably the definitive technology of the next era, governments are aggressively intervening. Through advanced export controls, they dictate exactly which countries can access the highest-end chips and EUV machines. Simultaneously, they're pouring billions into domestic manufacturing subsidies and crafting sovereign AI strategies. They've essentially become the ultimate referees of this global race.
The future of artificial intelligence may be written in code, but it will be built in factories, powered by grids, and limited by the hidden systems most people never see. The next time you marvel at an AI generating a complex response, remember the fragile, globally interdependent physical supply chain making it all possible. So, who truly controls AI? Everyone, and no one, all at once. Thank you for joining this explainer, and keep questioning the hidden systems that power our future.